Since 2019, the USBC equipment specification staff has conducted updated research looking at how bowling ball hardness changes over time after regular use. These research reports demonstrated urethane shell balls drop in hardness the most, while reactive shell balls have less significant changes, showing little to no drop in hardness after use. To address concerns over bowling ball hardness at the professional and bowling ball manufacturer level, this latest 2022 USBC Equipment Specifications Report summarizes research projects completed this year. The results provide clear data to allow bowling stakeholders to share a common set of facts, which are: urethane bowling balls get naturally softer with use. Lower ball hardness at manufacture clearly impacts performance. Chemically altering bowling balls to make them softer significantly impacts performance. This report outlines how these conclusions were reached and how this data relates to governance by USBC in this area in the present and the future. USBC's historical field test data, which are available on the equipment specifications pages on bowl.com, shows that urethane balls drop in hardness with use, and the drop in hardness eventually levels off at a certain point. These field tests also revealed that reactive shells showed little change in hardness after use, and that duplicating the USBC field test is difficult for a tournament operator because of the time, costs, and manpower required, as well as the number of variables that must be controlled to yield consistent results. In 2022, USBC conducted controlled lab testing on the two most popular urethane balls on the market to investigate the impact this softening phenomenon had on bowling ball performance, specifically looking at overall ball path, total hook, and entry angle. But before we get into the results of the tests, let's take a moment to understand the primary tool utilized for testing, as well as the history of the hardness specification in bowling. For over 50 years, the tool that has been used to measure the hardness of bowling balls is the Shore-D durometer. The tool was invented in 1915 and has stood the test of time as an accurate measurement tool used across a wide range of materials and industries. Shore-D durometers operate by having an indenter needle of a tightly specified shape press into materials under a regulated spring force and pressure. 1 point of difference on the scale relates to 1/1000th of an inch of penetration into the material. The American Society for Testing and Materials Standard calls for all calibrated durometers to be designed such that it is estimated that there is only a range of plus or minus 2 points of hardness across the thousands of calibrated durometers that exist. This means that any group of calibrated durometers testing the same material would be expected to agree on how far they penetrate into a material to a range of 4/1000ths of an inch. Measurement system analysis conducted on the durometer used in USBC's lab tests shows its gauge discrimination to be plus or minus 0.7 points, which is well within the acceptable range for calibration. The device is also calibrated regularly to ensure consistency. There are several factors that can affect durometer readings, such as material consistency, temperature, humidity, and test operation. This is also why durometer testing is best conducted in a laboratory environment, where the testing variables and procedure can be tightly controlled. USBC has published standard operating procedures to create consistency for these factors, which are available to all stakeholders. As far as the history of the bowling ball hardness specification is concerned, it is something that also goes back to the time when durometers were first used to measure hardness in bowling balls, approximately 50 years ago.
Hardness really came about because the pros back in the 70s started soaking polyester balls with a solvent and making them softer. And so at that point in time, USBC said, hey, we better set a hardness spec. The PBA set a spec at 75. We picked 72. Now, all the manufacturers want to get their balls on TV on the Pro Tour, so all the shells, they needed the ball to be above 75. Well, they can't make it at 75 and guarantee it'll be 75, so they were shooting for 77, 78. And for years, the PBA and at Nationals, we checked hardness of balls, and they always pass our 72 spec. I mean, because everything's being built at 78. And then at some point in time, the PBA said, everything's 78, we don't need our 75 spec anymore, we'll eliminate that. That immediately allowed the manufacturers to, 72s by now don't go below number. And so hardnesses of balls over the years, over the decades, have crept down closer to 72.